Okay, now I'm going to use example 3 to graph from general form. So I've got ax squared plus bx plus c format. My a value here, there's no number in front of x squared, so my a value is 1. My leading coefficient is 1, which tells me it opens up and there's no vertical dilation. So I have two choices. One choice is I could find the vertex using x equals negative b over 2a. So in this case, my b value is negative 6. So I would do the opposite of negative 6 over 2 times my a value, which is 1. So this becomes positive 6 over 2, which is 3. So to find my vertex, I would evaluate f of 3. On your chart, it says negative b over 2a is what you plug in here, but I already figured out what that value is. In this case, it's 3. So f of 3 equals 3 squared minus 6 times 3 plus 4, which is 9, minus 18 plus 4, so negative 9 and 4 is negative 5. So my vertex is located at 3, this number here, comma, negative 5. That's one way of doing that, and then you would follow the same thing as example 4, plot the vertex, use your parent table, and find your points from there. Another way is you can convert this using completing the square technique. So I would only recommend this method if your leading coefficient is 1, if a is 1, because it's a little easier to use completing the square without having to factor out any number in front. If you have a leading coefficient, my recommendation is go negative b over 2a and find it out that way. If you have a leading coefficient of 1, to complete the square is actually not too bad. So if you remember, f of x equals x squared minus 6x plus 4. What you're going to do is you're going to take this plus 4 and you're going to leave it a little bit of space. So you're going to write it to the right. So I've got a little bit of space here. Now to complete the square, you take your b value, you divide it by 2, and you square that, and then you add it to both sides. But because I'm kind of using the technique to rewrite my equation, I'm not going to be dealing with both sides. I'm going to stay on the same side. So if I add 1 to one side and I subtract 1 from that same side, it's like I never changed anything. If I add 2 and I take away 2, it's like I never changed anything. So I'm going to kind of use that little trick to complete the square. So in this case, my b value is negative 6. Negative 6 divided by 2 is negative 3. Now, if you remember, that tells you what you're going to factor to. So on my next line, I jump in and I say x, put this number here, minus 3, that quantity squared. Now, what am I actually doing to make that happen? I have to add b over 2 squared to both sides, or in this case, I'm going to add and I'm going to subtract. So this is 9. So I'm going to add 9, and then I have the plus 4, which I'm just bringing down. Now, if I add 9 and I stay on the same side, I'm going to take away 9, just so that it's like I never even changed the way the equation is. So this is the quantity of x minus 3 squared plus 9 minus 9. I'm sorry, this is where my plus 9 should go. The plus 9, go back here, I made a mistake. The plus 9 goes on this first line, so I do plus 9 minus 9. The plus 9 is what allows me to write this as x minus 3 squared. So I still have the plus 4 and the minus 9. So I can just simplify plus 4 minus 9, and this is minus 5. And now I know I did this right because we did the vertex a second ago using negative b over 2a. So my vertex was 3, negative 5, and now I'm in vertex form. And remember, it's hk. So my vertex is 3, negative 5. So from here, you've got all the information you need to graph. You can use your parent function, and you can put your vertex on there. So 1, 2, 3, and down 5. And it opens up, so I'm going to go, and it's a parent table, x, y, negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4. Here's my vertex. There's no dilation, there's no reflection. I'm just going to use these directions. So I'm going to go right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. And you're going to put in your sketch. And now we've got a graph from general form using a completing the square technique.